I'm going to do red as an example here. So I'm just going to fill out this column. You are going to then complete green, blue, and then I think purple's over here. So you're going to do the last three, but I'm going to do red for you. So it gave us wavelength. So in our two equations that are right here, wavelength only occurs, like it only appears in this one. C equals wavelength times frequency. This C is the speed of light. So that's the equation I'm going to use first. However, my wavelength is given in nanometers and the speed of light is meters per second. So I need to convert my meters to nanometers. I mean my nanometers to meters. So I have nanometers there. So 1 meter equals 1 times 10 to the 9th nanometers, which makes this 6.56 times 10 to the negative 7 meters. So again, I'm solving for red. So now that I've converted it to meters, now I can put it into my C equals wavelength times frequency equation. So I'm going to solve for frequency because that's going to give me my next answer here. So I'm going to solve for frequency, which means I'm going to divide both sides by wavelength. Whoops, that kind of looks like X, and it's supposed to be wavelength. Wavelength, there we go. Okay, so C is, let's see, where am I going to write it? I guess over here. So C is 3.00 times 10 to the 8th meters per second. And then wavelength, we figured out is 6.56 times 10 to the negative 7 meters. So our meters cancel, we're left with 1 over seconds, which hertz is the same thing as 1 over seconds. They're the same thing. So that's what we're solving for. So frequency, I'm going to come down here. So when I put all that into my calculator, I get 4.57 times 10 to the 14th hertz. Again, hertz, instead of writing hertz, I could write over seconds. Instead of writing over seconds, I could write seconds to the negative 1. So all of those units are acceptable, whichever one you want to write. The times 10 to the 14th is pretty common for frequency for a visible light range. So for all of these, you should be getting something times 10 to the 14th power. If you're not, you're putting it into your calculator wrong, and if that's the case, please let me know, and I'm happy to help. All right, so now that I found the frequency, I got 4.57 times 10 to the 14th. Because the units are here, I don't have to rewrite them. And now I'm going to calculate for energy. So I have my other equation here, my energy equation. So that's E equals HF. I'm solving for energy, so I don't have to rearrange my equation at all. H is right here, it's a constant, so 6.626 times 10 to the negative 34 joules times seconds. And I'm going to multiply that by my frequency, which was the 4.57 times 10 to the 14th over seconds. Remember, seconds to the negative 1. So my seconds here cancel, and I'm left with energy for joules, which is good because that's how I calculate energy. Those are the units for energy. And when I put that into my calculator, I get, 3.03 times 10 to the negative 19. Again, negative 19 is very common for energy when it's in this, when it's in a light, like a visible light range. So I'm going to write my answer in here. So 3.03 times 10 to the negative 19. So we're using both equations. We first use the speed of light one to calculate frequency, and then we use our energy one to calculate energy. The constants are right there. And again, you want to make sure you're practicing putting this into the calculators. All of your answers for frequency should be times 10 to the 14, and all of your answers for energy should be times 10 to the negative 19 for these next three problems. Really for any frequency or energy in the visible light range.